Hi colleagues, don't give up just because of difficulties, keep trying. Previously, we knew that around a conductor carrying an electric current there is a magnetic field. Well, these conductors have various shapes. One of them is a circle. Here's a problem. Let's read the question first. A circular conductor with a radius of 16 centimeters carries 16 amperes of electricity. Directly above the axis of the circle there is a point that forms an angle of 30 degrees to the edge of the circle. The question is, what is the magnitude of the magnetic induction at that point? Before answering this question, we will explain the concept first. You can skip this section if you understand the equation for magnetic induction in a conducting wire correctly. This is an illustration of a conducting circle, where the center of the circle is exactly at the coordinate center. Electric current flows counterclockwise. Using Biot-Savart's law, we can calculate the magnitude of the magnetic induction at a point on the axis of the circle. B is equal to mu0 I big R sine alpha over 2r squared. This big R is the radius of the conductor circle. R is the distance of the point to the edge of the circle. Alpha is the angle formed between the circle axis and the line R. Note, when the value of alpha changes, the value of R also changes. These two quantities are independent variables. So, this magnetic induction is actually a function of two independent variables, alpha and R. The values of other quantities are certain and fixed. We can write this equation into just one independent variable. Note that the coordinate axis, the R line, and the big R line form a right triangle. Using trigonometry concepts, sin alpha is equal to big R over R. Or R is equal to big R over sine alpha. Substitute this value into the magnetic induction equation. B is equal to mu0 I sine to the third power alpha divided by 2 big R. Now, we will identify the value stated in the question. There is an electric current I equals 16 amperes. This angle is the angle alpha. Alpha is equal to 30 degrees. And the radius of the conductor circle, big R, is equal to 0.08 meters. Get used to using the International System of Units. So, now we can calculate the magnetic induction value at the point in question. B is equal to mu0 I sine to the third power alpha divided by 2 big R. It looks like all the values are known. We can plug the known values into the equation. B is equal to 5 pi times 10 to the power minus 6 Tesla, or 5 pi micro Tesla. Hopefully it's useful. And thank you for watching this video.
Is this really happening? I can't believe it's true. I'm just as surprised as you.